Yes, good morning once again. You're on to the mathematics multiverse. And today we're looking at our grade. Notice I've had to put grade, think. It's just a new way I am coding my classes now to make learners a little more relaxed. You know, sometimes there's a way you can gather an experience and you'll be like, was this not higher than what I ought to know? Have I had that kind of feeling before? So it's grade. Technically, I'm referring to grade 7 audience, but anyone within the space of from your basic or your grade 4 to about grade 12 can really enjoy this experience. That's why you notice that there's a think added to this arrangement. So we're still on the matter of factors and multiple series, and we'll be looking at the matter of common factors. The word common will suggest that I have at the least two numbers I want to compare. So common will suggest that I'm comparing. I'm trying to find out, are there things that can connect the numbers together? Are there things that can connect them together? Notice how we said common factor. It means that we're looking for a number that can divide a set of numbers given to us. Let's take a practical example. For instance, if I have 16, I have 18, and I have 20. What is common to these terms or numbers given on the board is that they are all even numbers. And we know that an even number is any number that ends with or has its last digit as what? 0, 2, 4, 6, and 8. I call again 0, 2, 4, 6, and 8. I've heard here people say, or teachers will like, okay, a number that can be divided by 2. I usually have a problem with that because it's not too obvious. We know when you divide, a number divides, when you say 2 divides a number, you get it. If it's not divisible, you get a remainder. But I think it's easier when you tell me a number that ends or the last digit is what? 0. Or when I see the last digit as 0, 2, 4, 6, and 8. It's easy for me to relate with that, okay? So we discovered that what is common to all of this is what? 2. So common factor is 2. Now, this is just one possibility. Let me simulate another environment now. I have you discover that all of these numbers are even. Is that not? They're all even because their last digits are either 0, 2, 4, 6, or 8. But there's something more. If you check closely again, you discover that beyond these numbers being divisible by 2, they can all be divisible by 4. How do I know that? 4 times 1, 4, 4 times 2, 8, 4 times 3, 12, 4 times 4, 16, 4 times 5, 20. So in this setup, my common factors will be what? I can get 2 and I can get 4. Remember that the concept of factor is that I think of a number that can divide another number bigger than exactly it or bigger than it, such that I don't have a remainder. That's the concept of a factor. So in handling this, you must keep this in your mind while solving problems. So this is just a little description of what common factors are. We said that the essential thing is that they are factors, and we're looking at a set of numbers that a particular number can divide. So what we've done, you see that a common factor can be 1, and a common factor can also be more than 1. So now let's try to use methods now to solve this. And to help us with our work this morning will be no other than New General Mathematics for grade 7, JS1. I will be on page 17, exercise 3E. I'm not going to solve everything, but I'm going to pick a few questions that would strike a chord. All right, so we look at practice questions, exercises. All right, so we'll start with number exercise 3E. Let's pick, I'll start by picking question 1. Now, there are different methods for handling this. And I think for each question, I'm going to try to use 1, 2, or 3 methods so that you see what's happening. Now, if I pick 10, Z10 and 14, 10 and 14, maybe I should tag this first. Find the common factors of the numbers given below. So we're going to look for the common factors of the numbers given below. Now there's an extra twist to that. We're instructed not to add 1. So in this setup below, not including 1. So we are not to include 1 in this example, because when we start to treat common factors, we don't count 1 as a common factor. Come again, let me emphasize this. When we start treating common factors, we don't technically count 1. So except you are told otherwise, please push 1 out of it. Right, so let's get down to work. We look at number 1. It says 10 and 14. 10 and 14. So there are 2 methods we can use. I'll go back to my primary school, and this is what 10 equal to what? What is 10? I can break 10 to be what? 2 times 5. Let's look at 14. I can break 14 to be what? 2 times 7. If you remember our primary school approach, we look for what is common. HCF means when they say common factors, it means look for what is common. What are the things that are common? You discover that I'm seeing that 2 is common. I'm seeing 2 here, I'm seeing 2 here. So those is in my primary school, we usually circle it like this. Circle it like that. Okay, those 2 are common. This one is common too. So that means I have it in. So I will come here and I'll say common factor is equal to 2. Remember I said that technically we don't consider 1, but if we were to consider 1, it means that this term will have 2 common factors, 1 and 2. All right, we go to the next one. Number 2. Okay, I said there's another method you can use. So this is method 1. So let's call this method 1. And let's call this method 2. For most part, I would encourage you to use method 2. Okay, we think, but I think method 2 usually is the best for this. Personal opinion again. But by the time we start solving some questions, you discover that you need to understand what's happening in method 1. So for all the examples I will take, I'll use method 1 and 2. Now method 2, it will mean I'll use my concept of factor expansion method previously. So this will be what, 10, this will be what, 14. What is the rule for using this arrangement? Number 1, the numbers that must divide must be prime numbers. Or the numbers you must use here must be what? Prime factors. I hope you know that when we say prime number and prime factor, you understand the context in which this is used. We say a factor if it is breaking a bigger number. You get it? So a number in itself can be a prime and can be a prime factor when it is relating to another number. Right? So with this, we have 2 here. Why the choice of 2? Because they are both even. And when you're dealing with common factors, the number you must pick here must divide this and this. If it cannot divide both, please don't use it. When dealing with common factors, the number you must pick must divide this. The factor rather you must pick, or the prime factor you must pick must divide both this and this. Right? So this will be 5 and this will be 7. If you compare, there's nothing else that can happen. So I'll just simply say what? Common factor will be equal to what? 2. All right. So in this setup, we had our common factor to just be 1. So in method 1, we try to write this out. So 30 will be written in terms of what? The expansion in terms of its prime factors. So I can see it's an even number, so 2 will be there. If 2 divides 30, what will be left? 15. 15 will mean that I'll multiply 3 times 5. Now, I'll come to the next one, 36. 2 can divide this, I'll be left with 18. 2 can divide 18, I'll be left with 9. 3 can divide 9, I'll be left with 3. So that's the technique I'm using. I'm doing the mental division in my head. So with this, I can see 2 together, and I can see 3 occurring together. This was the method we're using back then in primary school. But you may not do this. All you need to do is that as long as you see 2, you see the numbers you're looking for, the prime factors up and down, or on the set of numbers given to you, you pick them out. So the common factor here now will now be what? I can see 2, I can see 3, and I can see 2 and 3. 2 times 3 will give me what? 6. So in this setup, we have 3 common factors now. I'm seeing 2, I'm seeing 3, and if I can see 2 and 3, it means I will see 6. So that's the common factors you're going to have. Right, now we use our method 2. I divide with 2. Remember the rule is that the number, the prime factor must divide both. 15, 18. 3 here will give me 5, and then what? 9. Nothing else. 3 will give me 5 and 6. Nothing else can be done. So my common factor now will now be what? I'm seeing 2, I'm seeing 3, and because I see 2 and 3, I must see 6. All right, so this will now be my final answer: 2, 3, and 6. So we'll take one more, and we're done with this. Take one more, and we're done with this. I'm trying to look for one that will stretch us a little. So let's look at 48, 60, and 72. 48, 60, and 72. Method 1 and method 2. Please take note that you're not required to use both methods to solve. I'm just doing it so that whichever method appeals to you, stick to it and use. But the reason why I would emphasize that you remember method 1 is because sometimes when we come to the next segment, you discover that if you are not conversant with method 1, if it comes out in the exam, it might become a challenge for you to even know that that's method 1 they have used. So I will have here 48, I will have here 60, I will have here 72. So how does it work? It's an even number, so 2 can divide it. If 2 divides 48, I'm going to get 24. 2 can also divide 24. I'm going to get 12. 2 can divide 12. I'm going to get 6. 2 can divide 6. I'm going to get 3. So this is what you're going to have. I just stretch this a little more. I'm sorry, since the other part, I wouldn't need much of. So it will be 2 times 2 times 2 times 2 times 2. Now, this is a callback to our expansion of any number into its prime factors. If you remember that exercise, this is where that knowledge becomes relevant. Now, for this one, it will be 2. 2 can divide 60, I'll get 30. 2 times 30. 2 can divide 30, that will be 15. 3 can divide 15, that will be 5. And that settles out. Now, I come to 72. What will I have? 2 can divide 72, I'll get 36. 2 can divide 36, I'll get 18. 2 can divide 18, I'll get 9. 3 can divide 9, I'll get 3. So this is what I'm going to have. So now, the next thing I'm going to do is to compare what is common. So I'm going to use another technique now. So common factors. So I'm seeing 2, 2, 2. So I could cancel. I'm saying 2, 2 all the way. Fine. I check. Can I see another 2? Yes, I can see 2, 2, 2 again. So common factor will be what? 2. I've seen 2. I've seen 2 twice. That will be 4. 2 times 2 is 4. So I'll put 4. Now I check again. What else can I see? I can see 3. There's no other 2 common. I can see 3. I'll put 3. If I can see 3 and 2, I can see 6. If I can see 4 and 3, I can see 12. So take note of when you're arranging this, you see what you need to critically look at. This and this. 2 index 2 is 4. So I can see 4. If I can see 4, then I can see 12. If I can see 2 and 3, I can see what? 6. So that takes care of method 1. In method 2, which is the one students love to use a lot. Students love this one so much. They love to use this method so much. So I'm going to have 48, 60, and 72. I always encourage this method because it's really very easy for people who don't want to stress themselves so much. Now, 2 will give me 24, 30, 36. I use 2 again to divide. Always write what you are using to divide before you write the answer. I'm going to get 12, 15, and what? 18. 2 cannot go again because I'm seeing an odd number here. So I'll try 3, 4, 5, and what? 6. So with this said, my common factor will be equal to what? I can see 2, I can see 3, I can see 4, 2 times 2 is 4, I can see 6, 2 times 3 is 6. Now, I can also see 12, multiply all of them together, I can see 12. So this gives me my common factors. So you see that in this setup, I'm having 1, 2, 3, 4, 5. 5 common factors. And this will bring us to the next concept we're going to go into. All right, welcome back. We're already conversant with common factors. We said that in common factors, we are comparing or trying to figure out what are the factors that are common to sets of numbers given to us. In this class, we're going to look at what is called the highest common factors. Just like in a competition, everybody can run. Or let's say a few students are very outstanding, but we still need to award somebody as the best student in the class. So the highest common factor is the best student among the factors. The one who has acquired the greatest number of marks gets the first position. So if you understand that, if you can relate with that, we'll go back to our third question we just solved. We came up with factors, common factors. Come up with common factors. But among these common factors, there is one that has stood out. And that is the highest common factor. So what's the highest common factor? The highest common factor is the best factor, is the highest factor among common factors given. So after solving and gotten your common factors, you now look for which one is the highest. If you look at it, this 12 is the highest. If you use method 1 or method 2, 12 will be the highest. So from here, we can now say the HCF is equal to what? Among the common factors given, the HCF will now be what? 12. So the highest common factor, the best student in the class, the most outstanding mathematician in the class is what we regard as the highest common factor. So the best of the best. So that answer becomes what? 12. So when reading your question in the exam, be careful to note whether they say, whether you've been told highest common factors or you've been told common factors. If they say common factors, likely the answer may be 1, 2, or 3 factors. When they say highest common factor, answer can only be 1. So take note of these as you solve problems. Okay, so let's go ahead and try to solve practical questions now. So still using our textbook of reference, the New General Mathematics for grade 7, we'll be looking at exercise 3F, page 18. We're going to be looking at different ways this question can be set, because it's important that once you understand the concept, it's important to know the different methods or different approach to setting questions here. So I'm going to be taking them one after the other, and I'm going to be taking aspects of it. So I'll take number 1. So I'll look at the first way it could be set. Remember, we're looking for HCF. Now, you could be, so HCF as products of prime factors. That's one way it could be set. HCFs are products of prime factors. The reason I'm emphasizing this is because more often than not, some struggles students have much later in this matter is born out of the fact that they didn't pay attention to this exercise. And that's why I'm emphasizing it. I'll just pick 1 or 2 questions. I'll pick 1. Now watch this. 2 times 2 times 2. That's question D. Question D of that exercise. 2 times 2 times 2 times 3 times 3 times 7. And I have another one. You see, a semicolon suggests that this is one number. After that number, you see a semicolon, means you should go to the next number. The next one says 2 times 2 times 3 times 3 times 3. And then the next one says 2 times 3 times 3 times 3 times 7. Now, these are the things that have been given to you to handle. These ones have been given to you to handle. Let's be sure that I copied the question correctly. I think I did that right. So sometimes they may not give you the number. They may expect you to write it out. They may expect you to process the HCF from here. So what would the HCF be? Now watch what I'm going to do. Very simple technique. Now we're trying to apply the knowledge now we have gotten previously. I will check through. I'm seeing 2 here, I'm seeing 2 here, I'm seeing 2 here. So that means must be 1 times. I see 2 here, I see 2 here, but there's no other 2, so I don't consider that one. I come to 3. I'm seeing 3 here, I'm seeing 3 here, I'm seeing 3 here. Always try to cancel that so you don't forget. I'm seeing 3 here, I'm seeing 3 here, I'm seeing 3 here. Look at it through. I can't see any other 3. 7 is here, 7 is not here, 7 is here. 7 is here, 7 is not here, 7 is here. So I can't consider 7. So what would be the HCF? They said we should leave it as product of what? Prime factor. So this is what they expect you to do and to leave your answer like. We can also go ahead. Let's assume we're told to find what the value will be. The value will now be 2 times 3. 6 times 3, 18. But remember that I am the one only doing this. The question says I should leave it as product of prime factors. All right. So that takes care of that. Now, you could have another method where they want you to, now number 2, HCF as what? A number. They can also want you to write the HCF as, or require you to write the HCF as just a number. So how do you do that? We take a case point. I'll pick any question I like. I'll pick a number. I'll pick a G. 42, 70, and 56. 42, 70, and 56. So whichever method you want to use, I'll use method 2. Let me just use method 2. If you like, you can use method 1. It doesn't matter. 42, 70, and 56. The first thing I observe is that they're all even numbers. They're all what? Even numbers. So 2 will divide this. 21, 35, and what? 28. Can 2 go again? No. Can 3 go? No. Can 4 go? No. Now remember, if 2 cannot go, or if 2 is not a factor, then no other even number will go, or no other what's the right word to use now? No other prime number will go. I mean, no other even, what am I even saying? 2 is the only prime number we have. So if 2 cannot go, it means you need to think of other numbers. Remember, we said that the factors you must put here must be prime numbers. They must be prime numbers or prime factors. So we'll try 3. 3 cannot. 5 cannot, because for 5 to go, the last digit must be 5. What else can go? 7. Can 7 go? We check our multiples. 7 times 1 times 2 times 3, 21, times 4, 28, times 5, 35. So you see that your knowledge of multiples is also very important in getting your factors. Factors and multiples are related. Towards the end of this course, we're going to show us the relationship between these two. So we have what? 7 here. 7 goes, we're going to have 3 here, 5 here, and then 4. So with that settled, we know that the HCF will now simply be what? 2 times 7. If you are told to express as product of prime factors, this is what you're going to have. But our answer becomes what? 14. Becomes what? 14. 2 times 7 will give us 14. Okay. So we go to the next one that says HCF as product of prime factors in index notation. HCF as product of prime factors in what? Index notation. So I'm going to give us, we're going to take an example here to work, and I'm going to take a question C that says 2 raised to the power of 2. Please pay attention to this one, because I'm going to be giving you keys that will shock you. You're going to see some things. See, a lot of the struggle you're having in maths is just born out of the fact that you did not see some keys. It is the keys you get at this point that will help you to unlock strange problems in mathematics. You get the keys right now, you see that a lot of problems in maths are just walkover. Now, times 3 raised to the power of 3 times 5 raised to the power of 2, that's the first one, separated by a semicolon, then 3 raised to the power of 2 times 3 raised to the power of times 5 raised to the power of 3 times. Maybe I should start with one that is a little lighter, because I think the concept art that I want you to see is rather deep. So let's take one that's a little light. Take one that's a little light so we can flow with that. Let me go with A. I just discovered something, so I don't push you too far. 2 to the power of 3 times 3 to the power of 2 times 7. 2 to the power of 2 times 3 to the power of 3 times 5 raised to the power of 2. 2 raised to the power of 2 times 3 raised to the power of 3 times 5. I hope I got that right. So that's the question you have. Now, remember we said that to get HCF, we must get numbers that are common all through. Is that not? So here I'm going to change my technique using getting with index form. I'm going to change my technique now. See what I'm going to do. Do I need to? Yes, I can see 2 all through. So I need it. Do I need 3? Yes, I can see 3 all through. Do I need 7? No. Because 7 is not seen all through. Do I need 5? No, I don't need 5. No, we don't need 5 because 5 does not occur all through. I can't see 5 all of them. Because I said the factor must occur all through. That's the concept of common factors. A factor I see all through. So I don't need 5. So I will come here to look at this. This is where the difference is. I will now look at all of them. I'll go back to 2 now. Look through 2. You will pick the factor is the number with the lowest index. Let that sink. Because this is what I've taught students for a while, and I discovered that when it comes to this, you expected to see this. And sometimes you see students spend a lot of time solving. So I want it to sink. This is my first official video in this line. The factor is the number with the lowest index. So if you look at this true now, this is index 3, this is index 2, this is index 2. So which one has the lowest index now? It is 2. If the index occurs twice, we pick 1. So I'll come here and say HCF will be equal to 2 raised to the power of what? 2 times. I will now go to 3. Please, you need to watch this video to get what has happened. Which one is the lowest index? This is 2, this is 3, this is 3. Anytime you write a number, it means that number is index 1. So it means that this is what? The lowest index. So this is the lowest index, and that will be times 3. Remember that we are told to write as product of prime factor in index notation. So this is what the final answer will look like. I wouldn't solve any other one. I want you to look at this again. That's why we've done a record. Watch this and then try to solve more. Now, this is not different from this. But the only real difference is that because of the way the problem is given. So I'll take an example to illustrate that idea. Now look at this. Let's say we are given, I'll take question 4B there. 144, 216, and 360. So anytime you are told to write in index form, I will advise you to use this method. This is the safest method to use. I call it what? The safest method for you to use. So you come 144, 216, and 360. So we're going to divide using prime factors here. This is an even number, so I must divide with 2. So 2 divide this, I'll have 72 here. I'll have 108. Please be careful here. 2 divide 2 will give me 1. 2 divide 1 is not possible, so I'll put a 0 down. This 1 moves to this position and provides support for me on the 6th digit to give me 16. Now 108. 2 divide 360 will give me 180. They're all even numbers, so 2 can still go. 36, 54, and 90. 2 can still divide. You may need to play this video, slow the video down, and then do it gradually and check whether what we have done is correct. 2 divide this, we have what? 18, 27, and what? 45. At this point, there's no 2 again. So we try 3. 3 will give me 6, 9, and what? 15. What do? We try 3 again. 3 will give me 2, 3, and what? 5. So with this, we are done with this one. So what's the HCF? So we should express as product of what? Prime factors in what? Index form. So don't waste your time. Look at the numbers you can see. I can see 2 and 3. So I'll just say 2 times 3. I count how many 2s I can see. 1, 2, 3. Yes. How many 2s can I see? I can see what? 3. 1, 2, 3. How many 3s can I see? 1, 2. So that will be the final answer. Maybe I should write this elsewhere. So this will be what? 2 raised to the power of 3 times 3 raised to the power of 2. So this is what the HCF would look like. That's what you're expected to do. Do we get it? So that's that for that. So with this, we have concluded the work on HCF. And then in our next class, we will be going into multiples. multiples. We'll be going into multiples. We're going into multiples, and then we trust that we'll be able to flow very well. Okay.